At 0347 hours on May 12, 1943, Captain Lieutenant Werner Hartenstein surfaced U-156 in the mid-Atlantic, 340 miles west of the Azores. Standard procedure? The Type ISC boat had been submerged for 11 hours. The diesel engines needed air. The crew needed to breathe. Hartenstein checked the horizon through his binoculars. Nothing. Empty ocean in every direction. Visibility was good, maybe 8 miles. The moon was down. Stars provided just enough light to see the wave tops. Perfect conditions for a surface transit. U-156 had been hunting. Convoy HX-237 for 6 days. Intelligence from Badu, U-boat headquarters in Berlin, indicated the convoy had 42 merchant ships with minimal escort. Hartenstein had fuel for another 18 days of patrol. He had 16 torpedoes remaining. The mathematics were favorable. The boat's METOX receiver was running. The device sat in the radio room, connected to a cross-shaped antenna mounted on the conning tower. METOX was designed to detect Allied radar transmissions at ranges up to 30 miles. When it picked up a signal, it emitted a distinctive warbling tone that gave crews enough time to dive before aircraft arrived. Since its deployment in August 1942, METOX had saved dozens of boats. Hartenstein trusted it completely. The METOX was silent. No warnings, no contacts, just the steady hum of the receiver scanning through frequencies. Then the boat exploded. Not an explosion, exactly. The starboard lookout saw it first, a bright flash 2,000 meters to the northeast, dropping from the sky. No sound yet, just light. Then the shockwave hit, a ley light, the most powerful searchlight ever mounted on an aircraft. 24 million candle power focused into a beam narrow enough to blind a man at 3 miles. The light locked onto U-156's conning tower. Hartenstein couldn't see anything except white. His night vision was destroyed instantly. His lookouts were screaming. The boat's silhouette was lit up like a stadium at noon. 4 seconds later, they heard the aircraft engines. Twin radials, probably a Liberator. The sound was already close, maybe 800 meters, and closing fast. Hartenstein screamed the order. Alarm, crash, dive, the klaxon shrieked. Men dropped through the tower hatch. The diesels shut down. Electric motors engaged. The ballast tanks opened. U-156 began to sink. But boats don't dive instantly. A Type I needed 35 seconds to get the conning tower underwater from a standing start. The aircraft was 12 seconds away. The first depth charge hit 40 meters from the boat's port side. The second hit 30 meters from starboard. The third exploded directly above the pressure hull. The fourth landed close enough that the shock wave bent the control room's depth gauge needle off its maximum reading of 200 meters. The detonations weren't fatal, but they didn't need to be. The shock bent the dive planes, cracked the battery compartments, ruptured the port diesel fuel tank, shattered half the light bulbs in the crew quarters. U-156 went to 90 meters with fuel streaming into the water behind it, creating a visible slick on the surface that would mark its position for hours. Hartenstein sat in the control room, listening to the leak detector's ping, counting the damage, and asking the only question that mattered: how did they find us? The engineering officer checked the METOX receiver. It was functioning normally. No malfunctions. No warnings recorded. The device had been completely silent until the moment the ley light hit. Either the aircraft had attacked without using radar, which was impossible at night over open ocean, or it was using radar that METOX couldn't detect. Hartenstein wrote in his patrol log, "Attacked by aircraft at 0347. No radar warning." METOX gave no indication of approach, evaded destruction through emergency dive but sustained significant damage, returning to base. He had just documented the weapon that would kill the U-boat force. He didn't know it yet. The answer was 40 miles away, mounted in the nose of a B-24 Liberator designated for Harry, flown by Flight Lieutenant James Walker of 120 Squadron RAF Coastal Command. Walker had taken off from RAF Aldergrove in Northern Ireland 7 hours earlier. His mission was simple: patrol a 400-mile sector of the mid-Atlantic looking for U-boats. The sector was empty. It was always empty. U-boats operated submerged during the day and surfaced only at night, and even then, only for brief periods. Finding one in 400 square miles of ocean at night was mathematically impossible. Except Walker had a new toy. ASV Mark III, the first airborne centimetric radar system small enough to fit in a bomber. The transmitter was magnetron, based operating at 9.7 gigahertz with a wavelength of 3 centimeters. The previous generation ASV Mark II operated at 1.5 meters wavelength. That difference, 3 centimeters versus 1.5 meters, changed everything. German U-boats had been equipped with METOX receivers since August 1942. METOX detected Allied radar emissions at ranges up to 30 miles, giving U-boat commanders plenty of warning to dive before aircraft arrived. But METOX was designed to detect wavelength transmissions. It couldn't hear centimetric radar. The physics were simple. METOX's antenna was physically too large to resonate at 9.7 gigahertz. A U-boat commander with METOX running would have no idea an aircraft with ASV Mark III was tracking him until the ley light hit. Walker's radar operator, Sergeant Dennis Cooper, had been watching the scope for 6 hours. The radar had a maximum range of 12 miles against a surfaced submarine. Minimum range was 800 meters. Closer than that, the radar's beam was too narrow to see the target. Cooper sat in the nose of the Liberator, watching the green phosphorescent sweep rotate across the circular display, showing nothing but sea clutter. The display showed range rings at 2-mile intervals and a bearing grid marked in 10-degree increments. Every time the antenna completed a rotation, once every 15 seconds, the image refreshed. Cooper had learned to distinguish submarine contacts from waves by their consistency. Waves moved. Submarines held steady course and speed. Then at 0347 hours, he saw a contact. Bearing 187 degrees, range 9 miles, small return, moving at maybe 10 knots, possibly a fishing boat. But there were no fishing fleets this far from land. Probably a submarine. Cooper called it out over the intercom. Contact bearing 187, range 9 miles, speed 10 knots. Designated target Alpha 1. Walker acknowledged. He had done this drill dozens of times in training. But this was his 4th operational patrol, and his first actual contact. He brought the Liberator around to an intercept heading, calculating the geometry in his head. The submarine was moving southwest at 10 knots. The Liberator was flying at 180 knots. Intercept time, approximately 4 minutes. Walker descended to 300 feet. The plan was rehearsed. Get within 2 miles, turn on the ley light, blind the lookouts, and drop depth charges before the boat could dive. The Mark III guided them all the way in. At 2,000 meters, Walker triggered the light. 4 million candle power. U-156 was perfectly illuminated. Walker saw men scrambling down the conning tower. He saw the bow dip as the tanks flooded. He saw the white wake churning behind the boat as it began to submerge. He armed the depth charges, 4 Mark She charges, set to 25 feet. The Liberator crossed over the submarine at 220 miles per hour. The charges fell in a perfect straddle. 2 seconds later, Walker saw the water erupt in 4 massive columns of white foam that rose 60 feet into the air and spread outward in expanding circles. He banked hard and came around for another pass. But U-156 was gone. Just an oil slick marking where it had been. Walker reported the attack at 0352 hours. Coastal Command logged it as a probable kill. They were wrong. U-156 survived. But they were right about something more important. The tactic worked. Centimetric radar plus ley light equaled dead submarines. Cooper shut down the radar and began filling out his contact report. Target bearing, range, speed, heading, time of initial detection, time of attack, estimated results. He included a note at the bottom. No apparent reaction from submarine until light activation. Target appeared completely unaware of approach. That note, buried in a routine operational report, documented the tactical revolution that was underway. U-boats couldn't detect the weapon hunting them, and they were dying because of it. Hartenstein brought U-156 back to Lorient, France on May 19, 1943. The boat needed 3 weeks of repairs. The damage list was extensive. Port diesel engine cracked, dive planes bent requiring complete replacement, 47 battery cells damaged and leaking chlorine gas, pressure hull seams weakened requiring re-welding, port torpedo tube outer door jammed. The boat had been lucky. 6 meters closer to any of those depth charges and the pressure hull would have cracked. Everyone aboard would have died. Hartenstein filed his patrol report with BDU headquarters. The report included a detailed description of the attack, the sudden illumination, the impossibly accurate bombing, the complete absence of radar warning from METOX. He noted the time, position, weather conditions, visibility, and his assessment of the aircraft type. He estimated the aircraft had approached from the northeast at approximately 250 knots, closing from beyond visual range with no advance warning whatsoever. Gross Admiral Karl D. Feynitz, commander of the U-boat force, read the report personally. D. Feynitz was not a stupid man. He had commanded U-boats in World War I. He understood submarine warfare better than anyone in the German military. He knew that tactics depended on information, and that information came from detection systems. If U-boats couldn't detect attacking aircraft, they couldn't defend themselves. D. Feynitz understood that something had changed. British aircraft had been attacking U-boats with increasing accuracy for the past 2 months. In March 1943, U-boats sank 108 Allied merchant ships in the Atlantic. In April, the number dropped to 56. In May, it dropped to 34. The decline was catastrophic. Meanwhile, U-boat losses were increasing. The 12th of March boats lost. The 15th of April boats lost. May, 41 boats lost. 41 submarines in 1 month. The highest monthly loss rate of the entire war. More boats than Germany could replace. The shipyards at Hamburg, Kiel, and Bremen were launching approximately 25 new boats per month. At current loss rates, the U-boat force would be extinct by autumn. D. Feynitz called a conference on May 24th. Every available U-boat commander was summoned to Paris for a tactical review. 53 commanders attended, representing every operational flotilla in the Atlantic. The question was direct. What is killing our boats? The commanders had theories. Korvettenkapitän Fen Reinhard Hardigan, who had commanded U-123 during Operation Drumbeat off the American coast in early 1942, argued that the Allies had broken the Enigma code and were reading German naval communications. They were routing convoys away from known U-boat positions and directing escorts to submarine patrol areas. Hardigan was right. Bletchley Park had been reading German naval Enigma since mid-1941, but nobody at the conference believed it. Enigma was considered unbreakable. The code used rotors that created 159 quintillion possible combinations. Allied codebreakers couldn't possibly have cracked it. Kapitän-Lieutenant Erich Topp, commander of U-552, with 34 ships, sunk, and one of the most successful U-boat aces, suggested that Allied destroyers had improved sonar. The new sonar could detect submerged boats at ranges beyond 3,000 meters and could track them while they were evading. Possible. But that didn't explain the aircraft attacks. Sonar didn't work from aircraft. Fragatankapit Fitten Heinrich Lehmann, Willenbrock, commander of U-96, proposed that METOX was defective or had been compromised. Perhaps the British had developed countermeasures that rendered METOX useless. Several commanders agreed. Their METOX receivers had been giving false alarms for weeks, triggering constantly even when no aircraft were present. Some had shut off their METOX entirely to avoid the distraction. This decision had probably saved their lives, though they didn't know it. Nobody suggested radar. Not because radar was secret. German scientists had invented radar in the 1930s, and Germany operated its own radar networks for air defense, but because everyone knew Allied aircraft used METR, wavelength radar, which METOX could detect. The idea that the Allies had developed a completely new radar operating at wavelengths METOX couldn't hear was technically plausible but seemed unlikely. That kind of development would require manufacturing precision Germany couldn't achieve. Surely Britain, with its bombed factories and resource shortages, couldn't do it either. The conference lasted 4 hours. The conclusion was operationally necessary, but strategically devastating. Nitz ordered all U-boats to remain submerged in the Bay of Biscay transit routes. No surface running at night, no exceptions. This reduced the boat's speed from 17 knots, surface to 7 knots submerged. It cut their operational range by 30%. It meant fewer patrols and fewer targets, but it kept the boats alive. The order went into effect on May 24, 1943. The results were immediate. In June, U-boat losses dropped to 17. In July, they dropped to 37. But sinkings of Allied ships dropped even faster. The 28th of June ships, the 3rd of July 7 ships, the 25th of August ships. The Battle of the Atlantic was turning. The U-boats were losing. Nitz knew the numbers. He had access to daily loss reports and intelligence summaries. He could see the trend lines at current exchange rates. The U-boat force was dying, but he couldn't explain why. His commanders were experienced. His boats were well built. His tactics were sound. Yet somehow Allied aircraft were finding submarines in the middle of the ocean at night with impossible accuracy. The answer was in the Atlantic, mounted in the noses of 87B-24 Liberators equipped with ASV Mark III. But Nitz wouldn't learn that for another 5 months. The weapon that turned the battle wasn't just radar. It was the combination of 3 technologies developed in parallel and integrated in early 1943. Centimetric radar, the ley light, and the long-range Liberator. Each component alone was insufficient. Combined, they created a system U-boats couldn't counter. The ley light was invented in 1940 by squadron leader Humphrey de Verdelais, an RAF officer who had previously served in the Royal Navy. Ley understood the fundamental problem of night attacks on submarines. Aircraft could find submarines using radar, but radar couldn't guide the final attack. Pilots needed visual contact to aim depth charges accurately, and visual contact at night required light. Natural light, moonlight, or starlight was insufficient. Aircraft needed artificial illumination. The concept was simple. Mount a searchlight on an aircraft and use it to illuminate submarines at night. But execution was difficult. The light had to be powerful enough to blind lookouts from 2 miles away. It had to be mechanically stabilized, so it stayed pointed at the target while the aircraft maneuvered. And it had to be electrically compatible with aircraft power systems that were never designed to support 24 million candle power. Ley's first prototype was tested in January 1941 on a Wellington bomber. The light weighed 125 pounds, mounted in a retractable turret under the fuselage. Power came from the aircraft's generators, which required modification to handle the electrical load. The bulb was a carbon arc type that produced a beam visible for 8 miles in clear conditions. The beam diameter was 18 feet at 1 mile, narrow enough to concentrate the light but wide enough to illuminate a submarine's entire silhouette. The first operational ley light installations happened in June 1942 on Wellington bombers of 172 Squadron, based at Chivanor in Devon. Results were mixed. The lights worked perfectly. Submarines were illuminated clearly enough for accurate bombing, but the aircraft couldn't find targets. ASV Mark II radar had a maximum range of only 5 miles at night, and its minimum range of 1 mile meant aircraft lost contact before reaching attack position. Pilots had to guess where the submarine was during the final approach. Most attacks missed. Between June and December 1942, Wellington bombers with ley lights made 67 attacks on U-boats. Only 4 attacks resulted in confirmed kills. The problem wasn't the light, it was the radar. ASV Mark III solved the problem. Development began in 1940 at the Telecommunications Research Establishment in Dorset, a secret facility dedicated to radar research. The key was the cavity magnetron, a vacuum tube that could generate high-power microwave radiation. British scientists John Randall and Harry Boot had invented the magnetron in February 1940, working in a laboratory at the University of Birmingham. Their device could generate 400 watts of continuous power at 3 centimeters wavelength, a revolutionary achievement. By 1941, British engineers had miniaturized the magnetron enough to fit in an aircraft nose. By 1942, they had integrated it with a rotating antenna and display system. By March 1943, the first production units were being installed in Liberators. The radar weighed 220 pounds, complete with antenna, transmitter, receiver, and display. Maximum power consumption was 3 kilowatts. The antenna rotated at 4 revolutions per minute, providing a full 360-degree scan every 15 seconds. The performance specifications were extraordinary. ASV Mark III could detect a surfaced U-boat at 12 miles in calm seas, 8 miles in rough seas. It could detect a periscope at 2 miles. The radar updated every 2 seconds, fast enough to track moving targets. The transmitter operated at 10 kilowatts peak power with a pulse width of 2 microseconds. The receiver's sensitivity was -90 dBm, which meant it could detect echoes 90 decibels below 1 milliwatt, a signal so weak it was barely distinguishable from background noise. The display was a plan position indicator, a circular screen with a rotating sweep that showed range and bearing to all contacts. Range rings appeared at 2-mile intervals. Bearing markers showed magnetic north and cardinal directions. Operators could see multiple targets simultaneously, track their movement, and calculate intercept courses. The system was intuitive enough that operators could be trained in 2 weeks, though becoming proficient took 2 months of operational experience. The Liberator was essential because of range. The B-24 had a combat radius of 1,000 miles, carrying a full weapons load of 8 depth charges plus defensive armament. This meant it could patrol areas of the Atlantic that had been beyond Allied air coverage. U-boats called this the Black Gap, a 600-mile WID E corridor south of Iceland, where no aircraft could reach them. The Liberator closed that gap. By April 1943, every square mile of the North Atlantic convoy routes was within range of land-based patrol aircraft operating from bases in Iceland, Northern Ireland, and Newfoundland. The integration of these 3 systems created a capability that didn't exist before March 1943. Aircraft could search for submarines using centimetric radar that U-boats couldn't detect. They could track submarines continuously from detection to attack. They could illuminate submarines with ley lights at the moment of attack, eliminating the need for moonlight or visual searching. And they could patrol for 12 hours at distances up to 1,000 miles from base, covering areas where U-boats had previously operated with impunity. U-boat commanders had no idea this technology existed. German naval intelligence knew the Allies were using some kind of improved detection system, but they didn't know what it was. Captured Allied aircrews were interrogated extensively. None of them had technical knowledge of the radar systems. They were pilots and gunners, not engineers. The radar operators who knew the details were under strict orders not to fly over enemy territory where they might be captured. If an aircraft with ASV Mark III developed mechanical problems over the Bay of Biscay, crews were ordered to jettison the radar before attempting an emergency landing. In July 1943, U-boats began reporting that METOX was triggering constantly, even when no aircraft were present. Some commanders theorized that the Allies had deployed decoy transmitters to make METOX useless. This was partly true. RAF Coastal Command had begun radiating decoy signals on meter wavelengths to force U-boats to dive unnecessarily, wasting battery power. But the real problem was that METOX couldn't hear the actual threat. Every time a METOX alarm sounded, commanders assumed it was a false alarm. Then a liberator would appear with centimetric radar and ley light, and the boat would be caught on the surface. BEBDU issued new orders in August 1943. All U-boats were to disable their METOX receivers and rely on visual lookouts only. The reasoning was that METOX false alarms were more dangerous than operating without radar warning. Boats were diving unnecessarily, depleting batteries, and missing targets. This decision was tactically correct based on the information available, but strategically disastrous. U-boats gave up their only electronic warning system just as Allied radar was becoming most effective. The numbers tell the story. In the first 6 months of 1943, Allied aircraft sank 31 U-boats. In the second 6 months, they sank 85. Of those 85, approximately 60 were attacked at night by aircraft using ASV Mark III and ley light. The average time between radar detection and attack was 8 minutes. The average time between ley light activation and the first depth charge impact was 14 seconds. U-boats had no time to react. By September 1943, U-boat commanders were refusing to transit certain areas. Not officially, refusing orders was punishable by court-martial, but through carefully worded patrol reports that emphasized mechanical problems, fuel shortages, or damage from previous attacks. Commanders found reasons to avoid the most dangerous zones. The Bay of Biscay, which U-boats had to cross to reach the Atlantic from their French bases, became known as the Valley of Death. Aircraft patrols were so dense that boats couldn't surface safely even at night. RAF Coastal Command had dedicated 120 Squadron, 172 Squadron, and 502 Squadron exclusively to Bay of Biscay patrols. These squadrons flew round, the clock operations with aircraft departing every 2 hours. The result was continuous coverage. Every 400 square mile sector had aircraft overhead approximately 60% of the time. Several commanders reported being attacked within 30 minutes of surfacing. One boat, U-386, was attacked 3 times in a single night by 3 different aircraft. It survived, but only by remaining submerged for 19 consecutive hours, which depleted its batteries to 12% charge, so low that the electric motors could barely turn the propellers. Captain Lieutenant Peter Creamer, commander of U-333, documented his bay crossing in September 1943. He surfaced on 7 separate occasions during a 3-day transit. Each time, he remained on the surface for exactly 40 minutes, the minimum time needed to recharge batteries enough for another submerged run. On 4 occasions, he heard aircraft engines before his lookouts saw navigation lights. On 2 occasions, he dove blindly based on instinct alone. No visual contact, no radar warning, just the feeling that something was wrong. Both times, aircraft appeared overhead within minutes. Creamer concluded that his survival was due to luck, not skill. D. Feynitz tried to counter the new tactics with technical and operational changes. In August 1943, he ordered all U-boats to be equipped with additional anti-aircraft guns. The standard loadout went from 120mm cannon to 137mm and 220mm cannons, plus a quad 20mm mounting on some boats. The theory was that boats could fight off aircraft instead of diving. D. Feynitz called this the fight-back strategy. This failed completely. Aircraft simply attacked from higher altitude where the guns couldn't reach. Most attacks came from 500 feet or higher, beyond the effective range of 20mm fire. or they attacked from angles where the boat's limited traverse couldn't track them. The guns could only elevate to 80 degrees, which meant aircraft diving from directly overhead were safe until the final seconds of their approach. Several U-boats were sunk while trying to fight back on the surface, their crews dying at their guns while depth charges exploded around them. U-441 was equipped with experimental heavy anti-aircraft armament. In May 1943, 2 quad 20mm mounts, 137mm cannon, and 120mm single mount. The boat was designated a flak trap, bait intended to lure aircraft into gun range. On its first patrol, U-441 engaged 4 aircraft. It damaged 2, but was itself heavily damaged by bombs and had to return to base. On its second patrol, it was sunk by a British Sunderland flying boat that attacked from 1,200 feet, too high for accurate anti-aircraft fire. The entire flak trap concept was abandoned. Feynitz also experimented with group tactics in autumn 1943. U-boats were ordered to travel in packs of 3 or 4, providing overlapping anti-aircraft coverage. This also failed. Multiple boats on the surface created a larger radar return, making them easier to detect. When one boat was attacked and forced to dive, the others often dove as well out of caution, leaving no surface support. Coordinating movement between boats required radio communication, which Allied direction, finding stations could track. Several group formations were intercepted and attacked before they even reached their patrol areas. In November 1943, German scientists finally recovered a centimetric radar set from a crashed Sterling bomber in the Netherlands. The aircraft had been shot down during a raid on Berlin and crashed near Rotterdam. Local Luftwaffe personnel secured the wreckage and transported it to the radar research facility at Kiel. The analysis took 3 weeks. The conclusions were devastating. The Allied radar operated at 9.7 gigahertz, a frequency German receivers couldn't detect. The transmitter power was 10 kilowatts peak, higher than German engineers thought possible from an airborne system. The receiver used a super heterodyne design with automatic gain control, more sophisticated than anything in German production. The antenna system was a parabolic reflector with a rotating feed, mechanically complex but highly effective, and the entire system weighed only 220 pounds, light enough to install in bombers without significantly affecting performance. German engineers calculated that developing a receiver that could detect 9.7 gigahertz radar would require at least 6 months of development work, assuming they could obtain the necessary components. Deploying such receivers across the entire U-boat fleet would take another 6 months after that. Total time, 1 year minimum. By then, the war might be over. Feynitz wrote in his war diary on the 18th of November 1943, "The enemy has rendered the U-boat ineffective through new detection methods, which we cannot counter. Our boats are being destroyed faster than we can build them. The current situation is unsustainable." This was as close as he ever came to admitting defeat. But he didn't withdraw the U-boat force permanently. He couldn't. Germany's strategy depended on cutting Britain's supply lines. Without U-boats, there was no way to threaten Allied merchant shipping. So the boats kept sailing, kept hunting, and kept dying. The actual moment the U-boat threat was broken happened on May 22, 1943, though nobody realized it at the time. That afternoon, Feynitz received loss reports from 7 U-boats in a 36-hour period. All were sunk by aircraft in the mid-Atlantic. 4 were attacked at night. None transmitted a distress signal before sinking, which meant they were surprised on the surface with no warning. Feynitz pulled a pen from his desk and calculated the loss rate. 7 boats in 36 hours meant approximately 58 boats per month. At current strength of 240 operational boats, the entire U-boat force would be destroyed in 90 days. The mathematics were undeniable. Germany was losing boats faster than the shipyards could build them. Even if production increased, which was unlikely given Allied bombing of German industrial centers, the loss rate was unsustainable. Defeynitz made the only decision that made sense. He withdrew all U-boats from the North Atlantic convoy routes. On May 24, 1943, BDU transmitted orders to all boats, break off operations, and return to base. The signal was intercepted and decoded by Allied intelligence at Bletchley Park within 4 hours. Analysts knew immediately what it meant. The U-boats had lost. The withdrawal wasn't permanent. U-boats returned to the Atlantic in September 1943 with upgraded weapons, acoustic homing torpedoes, improved schnorkel breathing systems, and more anti-aircraft guns. But they never regained the operational advantage they'd held in 1942. By the end of 1943, Allied aircraft were sinking U-boats faster than German shipyards could build them. In 1944, Germany launched 246 new U-boats. Allied forces sank 249. The mathematics were unsustainable. The final loss statistics are stark. From May 1943 to May 1945, Allied aircraft sank 288 U-boats. Surface ships sank 246. Mines and accidents accounted for another 94. Total losses, 628 boats. Of the 288 aircraft kills, approximately 175 were achieved using ASV Mark III radar. The other 113 were daytime attacks, or attacks guided by visual sighting. The centimetric radar wasn't the only weapon, but it was the decisive one. U-boat crews never knew what hit them. Post-war interviews with surviving commanders reveal that most believed Allied radar was simply more powerful, not operating on a completely different wavelength. Some thought the Allies had deployed networks of direction, finding stations that could track submarines by their radio emissions. A few believed Allied aircraft had some kind of infrared detection system that could see the heat from diesel engines. None guessed that the British had developed and deployed a radar system that operated at wavelengths their detection equipment couldn't hear. Korvetenkapit Finn Reinhard Hardigen, interviewed in 1946, described the experience. "We felt hunted by ghosts. Aircraft would appear from nowhere without warning and attack with precision that seemed impossible. We checked our equipment constantly. Everything worked, but it didn't matter. They found us anyway. The weapon was never seen because it was invisible." Radio waves at 3 centimeter wavelength are invisible to the human eye and undetectable by equipment designed for meter wavelengths. The U-boat commanders who survived later described the experience as fighting ghosts. Aircraft that appeared without warning lit up their boats like daylight and dropped depth charges with impossible accuracy. They knew something was guiding the attacks, but they didn't know what. And by the time German scientists discovered the truth, it was too late to matter. The technical achievement was extraordinary. Britain, fighting a defensive war with limited resources and cities under constant bombing, had developed a radar system more sophisticated than anything Germany could produce. They had manufactured it in quantity, over 1,000 ASV Mark III units by war's end, requiring precision components and skilled assembly labor. They had deployed it operationally faster than U-boat tactics could adapt. From first prototype in 1942 to operational deployment in March 1943, just 13 months. And they had kept it secret long enough for it to be decisive. Even after German scientists recovered an example in November 1943, Allied operational security prevented Germany from understanding the full extent of deployment. The invisibility wasn't just technical, it was strategic. The Allies never announced they had centimetric radar. They never mentioned it in propaganda or press releases. When U-boats were sunk, the official announcements credited improved patrol techniques or enhanced cooperation between air and naval forces. German intelligence analysts read these reports and assumed the Allies had better tactics, not better technology. British newspapers occasionally mentioned that new detection equipment was being used, but never provided details. American media followed similar patterns. The technology remained classified until after the war. By the time German scientists discovered the truth, it was too late to matter. Even if Germany had developed countermeasures immediately after capturing the Sterling's radar in November 1943, deployment would have taken until mid-1944. By then, Allied forces had landed at Normandy. The strategic situation had shifted. U-boats were no longer the decisive weapon. They were a diminishing threat, dangerous but manageable. After May 1943, certain convoy routes became effectively immune to U-boat attack. The route from New York to Liverpool, designated SC Slow Convoy, lost 142 ships in the first 5 months of 1943. It lost 23 ships in the last 7 months of 1943. The HX Halifax Fast Route lost 89 ships in early 1943 and 11 ships in late 1943. The reduction wasn't because there were fewer U-boats in the Atlantic. There were actually more boats on patrol in August 1943 than in March. In March, Bedu had 116 boats operational. In the 1st of August, 38 boats were operational. The difference was that Allied aircraft could find and attack them with near certainty. The statistics were kept by both sides and compared after the war. They tell the same story. In early 1943, a U-boat on patrol had approximately 40% chance of completing its mission without being attacked. By late 1943, that probability had dropped to 8%. In early 1943, a U-boat attacked by aircraft at night had a 70% chance of escaping by diving before bombs hit. By late 1943, that probability was 12%. The mathematics of survival had shifted completely. U-boat commanders learned to avoid specific areas. The approaches to British ports, which had been prime hunting grounds in 1942, became suicide zones in late 1943. Liverpool's western approaches, once the most dangerous waters in the Atlantic for Allied shipping, saw only 3 U-boat attacks in the last 4 months of 1943. All 3 attacks failed. All 3 U-boats were hunted relentlessly afterward. 2 were sunk. 1 escaped with heavy damage. The Bay of Biscay, once a routine transit route, required maximum caution. Some boats spent 3 weeks crossing the bay submerged, surfacing only for brief periods to recharge batteries. Their operational time in the actual patrol area was cut by 40%. A boat that previously spent 30 days on patrol in the Atlantic now spent 12 days transiting through the bay, 10 days on station, and 8 days returning, assuming it survived. The psychological impact was severe. U-boat crews knew they were being hunted by something they couldn't detect or counter. Morale declined measurably. Patrol reports from late 1943 describe crews refusing to surface at night, even when batteries were nearly depleted, at less than 15% charge, when standard procedure required surfacing immediately. Some boats returned to base without completing their patrols, claiming mechanical problems that post-inspection revealed were non-existent or minor. Commanders requested transfers to surface ships. One commander, whose name was redacted from post-war records, requested a court-martial rather than return to sea. Recruitment for U-boat training dropped by 60% between May and December 1943, forcing the Kriegsmarine to assign personnel involuntarily. Die Feinitz tried to restore morale with promises of new technology, revolutionary new boats that could stay submerged indefinitely, super torpedoes that couldn't miss, wonder weapons that would turn the tide. Some of these technologies existed and were genuinely impressive. The Type XIU boat could sustain 16 knots submerged, using battery power alone. Faster than most Allied escorts, it could dive to 280 meters, deeper than any depth charge could reach. It had advanced sonar and could fire torpedoes without surfacing. Acoustic homing torpedoes, designated T5 Zonk Feinig Ren, achieved hit rates above 50% against escorts. But these weapons arrived too late, and in too few numbers to change the outcome. The Type XI didn't enter service until 1945, when Germany was already losing the war on land. The acoustic torpedoes were deployed in late 1943, But Allied convoys quickly developed countermeasures. Noise, making decoys called Foxer, that lured the torpedoes away from actual ships. The Battle of the Atlantic didn't end with a dramatic final battle or surrender ceremony. It ended with a statistical collapse that played out over 18 months. Month by month, the exchange ratio shifted against the U-boats. In early 1943, each U-boat sank an average of 1.2 Allied ships before being destroyed or forced to return to base. By early 1944, the ratio had dropped to 0.3 ships per boat. By early 1945, it was 0.1. U-boats were being sunk faster than they could sink ships. The invisible weapon, centimetric radar, didn't win the Battle of the Atlantic alone. Ultra-intelligence from Bletchley Park allowed convoys to be routed around U-boat patrol lines. Long-range aircraft closed the mid-Atlantic air gap. Improved escorts with better sonar and more depth charges made surface attacks more dangerous. Escort carriers provided air cover in areas beyond land-based aircraft range. Each factor contributed, but centimetric radar changed the fundamental equation. Before May 1943, U-boats could operate on the surface at night with reasonable safety, relying on METOX to warn them of approaching aircraft. After May 1943, they couldn't. That single change was enough to break their operational effectiveness. The weapon that was never seen killed more U-boats than any other single system. Of the 175 submarines sunk by aircraft using ASV Mark III, the majority were attacked at night while surfaced, recharging batteries completely unaware they were being tracked. They had no warning, no countermeasure, no chance, just sudden light, sudden violence, and the ocean closing over them. In the end, the U-boat commanders were right to refuse to attack certain convoy routes after May 1943. Not because they were cowards or defeatists, but because they were professionals who understood the mathematics of survival. A weapon you can't see, can't hear, and can't counter will kill you. The smart move is not to fight. The smart move is to withdraw and find a different battle. They never got the chance. Germany's strategic situation required the U-boats to keep fighting regardless of losses, so they sailed and hunted and died, killed by a weapon they never saw until the moment the light hit.